Oil is heated on a stove. The temperature is modeled by the function f of x equals 100 minus 100 over x, where x cannot equal to 0. 1. Use your GDC to sketch the graph of the function for x is greater than 0, 50 is greater than or equal to x. The function f of x equals 100 minus 100 over x is a reciprocal function. However, it seems to appear as a straight line. For that reason, we were to change the range of the graph, permitting us to observe the curve. To change the range, you go to Menu, Window/Zoom, Window Settings, change the x minimum to 0, we change the x maximum to 50, y minimum to 0, and considering that 50 is the x value, I substituted x as 0 to observe the horizontal asymptote. I got 100, thus I entered y maximum as 100. Two. Find the temperature of the oil after 10 minutes. The temperature after 10 minutes is 90 degrees Celsius, as when x equals to 10, y equals to 90. There are many possible ways of obtaining the answer, such as substituting the answer and finding x or y through algebra, or using the graphics calculator and looking at the table of values. Knowing that time is the x-axis, and in this case, our x variable is 10, and then follow through the algebraic process, making y 90 degrees Celsius. However, using algebra is my preferable method as it is reliable and provides precise answers. Using your graphics calculator, you can go to Menu, Split Screen Table, go down so x equals to 10, y equals to 90. 3. Find the number of minutes that it takes for the temperature to reach 30 degrees Celsius. It will take 1.43 minutes to reach 30 degrees Celsius. As you are aware of the value of the y-axis, it is possible to substitute that back into the original equation. Or, as y equals to 30, we go to Tab, enter 30 as the y value, and observe the point of intersection. We go to Menu, Analyze Graph, Intersection, that method was also accurate and time-saving. 4. Write down the maximum temperature that the oil can reach. Maximum temperature that the oil can reach, based on our graph, is 98 degrees Celsius, when y equals 98, x equals 50. Again, more than one method. Or use your GDC to go to the table of values. Menu, Split Screen Table, go down so x equals to 50, y equals to 98. What can you say about the asymptotes and the significance of x in the equation? X is a significant value in this equation as it proclaims the horizontal asymptote, which in this case is 100. X as an unspecified term is placed in this equation and is subsequently replaced in values such as 1, 2, 3, 4, 5, etc. Those values create coordinates which can be plotted on the graph. As large as the x-axis may be, value 100 on the y-axis will not be intersected or reached. The x in this equation creates an infinite range for the x-axis. As the x-axis increases in range, the y-axis values increase and get closer to 100 in the form of a decimal. As asymptotes are imaginary straight lines that continually approach a curve but do not meet them at any finite distance, this equation clearly indicates and exhibits that y equals 100 is the horizontal asymptote because the curve appears to resemble a straight line, reaching 100, but never develops into one. Meanwhile, the range of the x-axis increases from 50 onwards. Consider the parent function, 1 over x. If x was very large, y would be very small. For example, however, if x was very small, y would be very large. For example, the equation I was given, however, is contrasting to the parental function, as it has a constant, 100, that the fraction 100 over x is subtracted from, and reverses the process. In conclusion, I'd say that as x increases, y increases. X is a significant part of this equation as it permits a person to be aware of the horizontal asymptote. And it also creates a continuous and a boundless curved line. X cannot equal to 0 because you cannot divide a number.